Okay, this is a review about everything that we've went over second quarter. Okay, we learned about the Pythagorean Theorem during second quarter. The Pythagorean Theorem only applies whenever you have a right triangle, and you should always find the hypotenuse first. Pythagorean Theorem is a squared plus b squared equals c squared. A and b are your side lengths. Those are the shortest sides. So you have side squared plus side squared equals the longest side squared. Okay, an example of this would be if you had a triangle where one side length was 24 feet, another side length would be 10 feet, and you were missing the longest side length. You can find the longest side length by using the Pythagorean Theorem. And in this situation, we are finding the hypotenuse, which is C, because it's directly across from the right angle. So we would use the other two side lengths, 24 and 10, and square those numbers to find the longest side length, which is C. So you do 24 times 24, which is 576. 10 times 10, that's 100. And that equals 676. And this is equal to c squared. We want to know what the hypotenuse or the side length is. We don't want to know what the side length squared is, so we want to take the square root of whatever number we come up with so we can find out what c is, not c squared, just regular c. The square root of 676 is 26. So our answer would be 26 feet. Which for this side length to be 26 feet, it makes sense because this is the longest side length and my other two lengths for my sides are 24 and 10. So another topic that we covered second quarter was linear equations. Okay, you can solve linear equations when you move numbers from one side to the other and do the opposite of what's being done. Doing the opposite of what's being done is the same thing as an inverse operation. And linear equations are talking about an equation that represents a line. And we're talking about straight lines. Okay, an example of this would be u minus 9 equals negative 7u plus 7. Now here are the steps to solving the linear equations that we went over during second quarter. We solve them by distributing any parentheses if necessary. You solve the exponents, then you combine like terms, you isolate the variable by adding or subtracting, and then you isolate by multiplying or dividing. Okay, in this particular problem, we're going to check first to see, do we distribute any parentheses? Since there are no parentheses, then we can skip this step. We've already checked to make sure that there's nothing to distribute. We don't have any exponents, so we don't have to do any of that. Combine like terms. On each side, you have u's and you have numbers. So you have variables and numbers, so you don't have to combine like terms. I know that I have to add 7u to both sides in order to get all of my variables on one side and all of my numbers on the other side, but this is not called combining like terms. This is called isolating the variable. So I just did step 4. Isolate the variable by adding or subtracting. So since negative 7u was negative, I would add 7u to both sides. That would cancel it out on the right side and leave me with 8u on the left side. And then I would just bring down everything that I had left over. Now I can move my number to the opposite side by adding. And again, that cancels out. And then I'm left with 8u equals 16. And so I'm finished isolating the variables by adding or subtracting. Now I have to isolate the variables by multiplying or dividing. Since 8 is being multiplied to u, I'm going to do the opposite, which is to divide by 8 instead of multiplying by 8. So u would equal 2. And that would be my answer. Alright, we also learned about square roots and perfect cube roots. So a square root is a number multiplied by itself Okay, for instance, it would be like if I wanted to know 5 squared, that would be a number, 5, multiplied by itself 5 times, and you get 25. So you're supposed to have all of these memorized, all the perfect square roots. So 1 through 15 and 16 through 25. Okay, the opposite of squaring this number, when we square 5, we got 25. But the opposite of this would be to take the square root of it, and the square root of 25 is 5. Okay, we also learned about perfect cube roots, and that's a number multiplied by itself 3 times, okay, to get the product. So for instance, if I took 2 cubed, 2 cubed is writing the number 2 3 times and multiplying it. So it'd be 2 times 2, which is 4, times 2, which would be 8. And the opposite of cubing something is to take the cube root, which looks like a square root, but it has a exponent of 3. So the cube root is 2, because that tells me I need a number that I can multiply by itself 3 times to get the product of 8. Another topic that we covered second quarter was estimating and approximating square and cube roots. There's a difference between estimating and approximating. When you're estimating between what 2 integers a square root is, if it's an imperfect square root. And when you're approximating, you're trying to find the closest square or cube root possible to the nearest hundredth of a particular square root that's not a perfect square root. So I'm going to begin with estimating, and when you estimate the square root, you have to look at it like as if it would be on a number line. So if we looked at a regular number line, given 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we placed our square roots on the same number line above the number that they represent, like let's say 0 squared, well, that would be 0. And 1 squared would be 1. 2 squared would be 4. And then the square root of 4 would be 2. Okay. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. And the square root of 100 is 10. So if you were given a question that says estimate what two integers the square root of 30 is between, we would look at where the square root of 30 was on our number line. So the square root of 30 is between the number 25 and the number 36. So the square root of 30 would be between the number 5 and 6. So the answer to the square root of 30 would be between 5 and 6. So when it asks you to estimate what two integers is the square root of 30 between, we would say that it would be between 5 and 6. And that's how you would estimate. Okay, if I wanted to take the same information, but instead of asking what the estimate would be for the square root of 30, if I wanted to approximate I would do this by starting with the same information that I was given for my last problem. Whenever I went to estimate it, I would estimate this as being between the square root of 25 and 36, which we are looking at the square root of 30 as an imperfect square, and we need to find two perfect squares where it's between. So it would be between 25 and 36. The square root of 25 is 5. The square root of 36 is 6. So we know our answer is going to be between here. So our answer is going to be between 5 and 6. So it means our answer is going to be 5 point something. We can use this trick, which I call it the L trick, because you're finding the difference between 30 and 25, which is 5, and the difference between 36 and 25, which is 11. And you divide these two numbers, 5 divided by 11. That gives you 0.4445. And we can use this to the right of our decimal place to approximate. So our answer for the square root of 30 would be 5.45. Or we could estimate that to 5.5. And that's how you approximate.